All right, hello and welcome back. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite system and network attacker. And today we are going through the Intro to Endpoint Security module that is available at TryHackMe at their SOC Level 1 pathway. So we've done a lot of these videos already, and all of these exist on the channel, so you're more than welcome to go through all these things. But today we're going into the endpoint security module and all of these different individual sub modules. And as of right now, we're doing the intro to endpoint security. Real quick, before I get started, just wanted to kindly and humbly request that if you like anything from this channel, or if you've gotten any value from me at all whatsoever, it would be more than honor and a privilege for me if you could like and subscribe and turn on the notification bell and even drop a comment, because all of that helps so much with the YouTube algorithm. And that's really the only thing that I want from you. I'm doing all of this stuff for free. I will post multiple times a day, at the very least once a day. And all of this is available to you for free. And you're more than welcome to go through this content. And it would just help me out a lot, because I'm trying to build this channel up and grow the community and add value to as many people as I possibly can. So it would be very, very lovely, and it would honor me, and it would be a privilege for me if you would end up following and subscribing and even sharing, telling your friends about it, so on and so forth. So all of that helps the algorithm and helps us grow. So that's basically it. That's all I'm going to say. Now let's actually, without further ado, let's jump into the introduction of the room. Okay, so the room, we're going to be going through the fundamentals of endpoint security monitoring, the tools that are involved, and the high level kind of an overview of finding a malicious activity from an endpoint. And your computer could be an endpoint, an IoT device could be an endpoint, a server could be an endpoint, and then mapping the related events to that endpoint. To start, we're going to tackle 3 specific topics. And learn how to kind of deal with the endpoint security monitoring task in general. One of them is going to be the fundamentals of endpoint security. The other one is logging and monitoring. And the last is log analysis. So by the end of this, we should have a threat simulation where we can actually investigate and remediate some of the infected machines. And it may require first to understand the fundamentals. So obviously, we're gonna go ahead and do that. So let's actually run into it and let's see what we can learn here. All right, the endpoint security fundamentals. So first thing, there's the core Windows processes. Before doing anything else, we need to understand of how Windows operating system works without any kind of knowledge. Differentiating an outlier from a haystack of events could be problematic. So trying to find a needle in the haystack is basically what they're talking about. A built-in network tool named Task Manager can help us understand what goes on inside that. And Task Manager, I used to use it just to end certain things that weren't operating, but it actually is very useful. So it's a GUI, graphic user interface tool that allows us to see what's running. And it provides information on the usage, such as how much each CPU each one is using, how much RAM each one is using. And if it's not responding, you can use it to force the thing to end. And that's what I used to use it for all the time. When a program stopped responding, I would do Control-Alt-Delete, Task Manager pops up, and then I would force the thing to stop running. So it provides some of the core processes running in the background, and a lot of these are considered normal behavior. So this little / or the greater than symbol represents a parent-child relationship. So if you see system and SMS exe, the system is the parent, the SMS is the child of it. So we have the system and a system SMS. Then we have CSRSS, win in it, and then services under that, and then SVC host under that, LSAS, Win Logon, Explorer, so on and so forth. So the processes with no depiction of a parent-child should not have a parent process under normal circumstances, except for the system process, which should have a system idle process as its parent process. And we can refer to the core Windows processor room to learn more about this. Let me see if I've even started this at all. I don't think I have. Yeah, I don't recognize it. So that's a whole other thing that I probably need to learn and go into just to get a better understanding of it. Sysinternals, we can see what this does. It's a compilation of 70 plus Windows-based tools. Each of them fall into the following categories. So out of all of these 70 fall into one of these things. File and disk utilities, network utilities, process, security, system information, and miscellaneous, which probably covers a lot of things. We're going to go into two of the most used ones, which is TCP Overview, which is a networking tool, and Process Explorer, which is a process tool. TCP View, it shows detailed listings of all TCP and UDP endpoints on the system, including the local and remote IP addresses and the state of all the TCP connections. On 2008 Vista XP, TCP View also reports the name of the process that owns the endpoint, and it provides a more informative and better presented subset of the netstat program, which is kind of like a command line, but I think netstat also has a GUI. And the download, this TCP View download includes the TCP vcon, which is a command line version of the same thing. So this is what that looks like. And so this is the process, the ID, the protocol, the local address, the local port, so on and so forth. Every connection is listed by the tool, which may aid in correlating network events executed concurrently. Then we have the Process Explorer, and it has two sub windows. The top window always shows the list of everything that's active, including name of the owning accounts, and the information displayed in the bottom window depends on the mode that the Process Explorer is in. If it's in handle mode, we're going to see the handles that the process selected in the top window is actually opened. If it's in Explorer mode, if Explorer is in DLL mode, you'll see the DLLs and memory mapped files that it's loaded. And so in this particular case, we're looking at the services, the web client that's running, and that is DLL. So I'm guessing this is the DLL mode that we're looking at. So it enables to inspect the details of a running process, such as associated services, network traffic, handles like files or directories that have been opened, and memory mapped or DLL files that have been loaded. So to learn more about this, we can go into the sysinternals room, and all of these things I don't even recognize, so I probably need to actually go and do all of that just to get a better understanding of this. So what is the normal parent process of services.exe? That's our first question. And I believe that is wininit.exe. There we go. What is the name of the network utility tool that has been introduced in this task? And that would be TCP View. So now we got this task under our belt, and we can move from fundamentals into logging and monitoring. Endpoint logging and monitoring. So we just learned that the Windows OS has some baseline processes and tools to analyze events that are running on the machine. This only limits us from observing real-time events. With this, we're going to go into the importance of logging. So there's event logs. They're not text files and can be viewed inside a text editor, but the raw data can be translated into XML using the Windows API, and the events are stored in the proprietary binary with the EVT or EVTX extension, and it's typically inside this place right here. There are three main ways of accessing these logs: the event viewer, the WEV utility, and the getWin event, which is a PowerShell commandlet. So we can look at logs in one of three different ways. This is the event viewer, which is the graphic user interface. And so if we go under Windows logs, under security, and then we can just see all of these different logs that exist right here. And of course, there's an event logs room for Windows. And then there's sysmon, system monitor, to monitor and log events on Windows. As a part of the sysinternals package, it's similar to Windows event logs with more detail and control. It gathers the detailed and high quality logs, as well as tracing, to try to identify anomalies. It's used with a SIM, so Security Information and Event Manager, or other log parsing solutions that aggregate, filter, and visualize events. It includes 27 types of event IDs, all of which can be used with the required configuration file to specify how they should be handled and analyzed. An excellent example of this is created by Swift on Security, and it's in this link. I think this is an external link. Yeah, it's a GitHub for Swift on Security sysmon configuration. So you can go look at that at your own leisure. The image below shows an example sample set of sysmon logs with the event viewer. And so these are all of our logs. Very unexciting. And of course, there's a sysmon room that's available to us. So OS Query is an open source tool created by Facebook. Look at that. Security analysts and incident responders, threat hunters can query an endpoint or multiple endpoints using the SQL syntax. It can be installed on a bunch of different places. To interact with this, we use command line or PowerShell, and we just run OS Query I, and you'll know that you successfully entered when it actually changes into OS Query instead of what the normal line looks like. And so when you're in here, you can do select PID name path from the processes where the name has this in it. And so it will do that for you. So the PID from LSAS, and this is the path, right? So it only allows you to query events inside the machine, but with Collide Fleet, you can query multiple endpoints from the Collide Fleet UI instead of using OS Query locally. A sample of Collide Fleet shows that the result of a query listing the machines with LSAS process running. So basically, we would just kind of look into it. Looks like it's a GUI type of a thing. So one host returning 95 records. So they searched for LSAS in the command line, and it brought it up. So there's that. And of course, we can go to the OS Query room if we want to learn more. And this is either Wazoo or Waza. So it's an open source, free available EDR solution that security engineers can use. It operates on a management and agent model where a dedicated manager is responsible for managing agents installed on the device. As mentioned, Wazoo is an EDR, so endpoint detection. Let's briefly run through what EDR is. Endpoint detection and response are tools and applications that monitor services for an activity that could indicate a threat or security breach. These tools and applications have features that include auditing a device, proactively monitoring a device for unauthorized stuff, visualizing complex data, recording a device's normal operating behavior, and a sample of Wazoo looks like this. So you have what looks like the dashboard, and it kind of filters it further for you. And so if we just wait for it, so we can add a filter, and then the name of the filter would be log on, for example, and it chooses whichever one. And then from there, you add an operator, it exists, and then it brings us all of those things for you. To gain more experience, we can go into the Wazoo room. So where do the Windows event logs files typically reside? And that is right at the top right here, this thing. So we can just copy this and go all the way to the bottom, and it will be our answer. Provide the command used to enter OS Query CLI. So it's OS Query I. And what does EDR mean? So it's endpoint detection and what was it? What does the R stand for? Response. There is that. Okay, moving right along. We are now going to go into Endpoint Log Analysis. All right, endpoint correlation. And there's a site that's attached to this, so that should be interesting. Event correlation is significant relationships from multiple log sources. It deals with identifying significant artifacts from different log sources and connecting them to each other if they're related. For example, a network connection log can have a lot of log sources such as sysmon, event ID 3 connection and firewall logs. The firewall log may provide the source and destination IP and port, protocol, action taken. In contrast, sysmon may give the process that invoked the connection and the user running the process. So we can connect the dots of each artifact from two sources. So source, destination IP, and port, action taken, protocol, process name, user account, machine name. Event correlation can build the puzzle, so it kind of connects everything. Now you have a baseline, is the process of knowing what is expected to be normal, right? So in endpoint security monitoring, it requires a vast amount of data gathering to establish the baseline. So what's standard? And using the baseline as a reference, we can quickly determine the outliers. So if you have a baseline, you can see what's out of the ordinary, basically. It's a sample list of baseline and unusual activities, right? So just as an example, a single workstation is assigned to each employee. A user has attempted to authenticate to multiple workstations. That's kind of one of them. In London, the regular working hours are between 9 a.m. to 6 p.m. User has authenticated via VPN in Singapore from 3 a.m. All of these things are kind of, this is the baseline, and then this is what's out of the ordinary, right? So this is the general approach, and I mean, you're more than welcome to pause this and kind of read that as an example. Any event could be a needle in a haystack without a good overview of what the baseline should be. So investigation activity, we've gone through some foundations. So now we're going to try to see what's going on. So we opened up that site on the side, and it says provide the flag for a simulated investigation activity. So let's see what we can actually find on the side right here. So this machine has been compromised. Identify and remediate. So identify the abnormal running process. You may open the baseline document to see what is normal. Can I move this to the side? I can. So I can't move this to the side. I can't shrink it, nothing. So we have CSRSS, SMS, WinInit, WinLogon, Explorer, and SVC host. So Explorer, SVC host, WinLogon, SMS, Beacon. That's the one. So that's the one. Okay, now what? Oh, I see. Now, based on the identified malicious process, determine the malicious network traffic. You may refer to the notes. So it says I mean, this is it right here. So Beacon, process ID, port 4444. 443 is the HTTPS port, so that seems pretty normal, and the process name has SVC host, so we can just take care of that. And now this is the IP address. So find all machines affected using that. So we're going to search for 2348.195 right there and search for that. And these are all of the ones that have been affected. So remediate, 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 remediate. And you have successfully eradicated the threat. You may now get the reward, which is the flag txt on the file right here. And there is our flag. Very straightforward, very, very simple, and kind of easy to understand, right? So there you go. And finally, let's jump into the conclusion of the room. All right, so we completed the room. Now we have an understanding of what a baseline is and why it's so important to kind of establish or try to find anomalies. Event correlation provides a deeper understanding of the concurrent events, so things that are happening all at the same time or connected to each other. Taking note of each significant artifact is crucial. Other potentially affected assets could be inspected and remediated. We covered security fundamentals, logging and monitoring, and log analysis. There's all of these other things that are available, and I feel like this is going to be a part of this path. So we have core Windows processes, which is next, sysinternals, Windows event logon, sysmon, all of these things are a part of all of the stuff that we're about to learn. So we are literally just going to be kind of going from one after another to just try to connect all of these things together. So there is that. We have an understanding of endpoint detection and endpoint security. And from here, we're going to jump into the next task, the next room. If you found this information useful, if you learned anything from this video, and if you want to show your support, I would very much love it if you could like, subscribe, turn on the notification bell, share the channel with the people that you know that might be interested in this, and leave a comment in the comment section, because all of those activities help us with the YouTube algorithm so that we can get more reach and try to expand the community and grow the channel, so on and so forth. It would mean a lot to me, and that's really all I ask from you. And hopefully I'll see you in another video. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker. And peace, love, and chicken grease. If no one else loves you, Hank loves you. I will see you in the next room.